Alright, let's look at the homework 15.5, problem number 2. Alright, so we have half disk region here, and we want to find the mass first. Let's do that. Alright, so mass is simply double integral of the density over the region D, right? And the density is given to be k times square root of x squared plus y squared. Alright, so if you rewrite that in polar coordinate, k would still be k, right? And x squared plus y squared is equivalent to r squared with square root, so it's going to be simply just r, right? So let's check the answer. So submit for testing. Alright, it came back and looks like we got this one correctly. Alright, so next one, we're going to pull k outside here. And then you combine this r and this r here, because there's a r as a part of the area element. So it's r squared. Alright, then we want to find the antiderivative of r squared. Actually, looks like it's okay. All right, so what they did was they separate the integral first. So this is going to be an integral from 0 to pi d theta, right? So antiderivative 1 is theta, plug in pi and the minus 0. So that gives you pi, this pi right here. All right, so that comes from the first, this outside integral. And the k is right there. So if you take the antiderivative r squared with respect to r, you end up getting r cubed over 3, right? Then if you plug in a here, so you have k pi a cubed over 3. So I'm going to just say k pi, and actually k pi, right, doesn't, oops. Hold on a sec, I can't get pi there. I'm going to say pi. Right, I got the k pi and a cubed. So I'm going to put the a cubed and over 3. Right, so let's check the answer. Alright, submit for testing. Alright, it came back and looks like we got all these guys correctly. Alright, let's move on here. Right, both the lambda and the density functions are symmetric with respect to y-axis. So the center of the mass lie on the y-axis, which means that the x bar is going to be just 0, because that way it's going to be right on the y-axis. Right, so go ahead and check that. Alright, submit for testing. Alright, so we got that, and we want to find the y bar. Alright, so y bar can be found by, alright, so this double integral is going to give us the total moment, and then with respect to x-axis, and then we just divide by the total mass. Alright, so let's do that. Here we just turn it into converted in polar coordinate. So y becomes r sine of theta, as we knew. And then the density is kr. Then dA is r dr d theta. So we have that. All right. So we're gonna separate the integral. You have a sign here, and all the r's here. So how many are r here? There's r. So 3 r's. So it's going to be kr cubed. So this is going to be kr cubed. All right. Now I'm going to integrate. So antiderivative sine of theta is negative cosine of theta, going from 0 to pi. And the antiderivative of this guy is k, and r to the 4th power divided by 4. Right? So what do we get here? Right? If you plug in pi here, right? So cosine of pi is negative 1, so it's going to be negative 1 negative. So it's going to be positive 1 minus, all right, negative positive cosine of 1. So it's going to be 1 plus 1, all right? So that's going to be 6. It's 2 times 3, so I'm going to go ahead and put that right here. I'm going to put the 6 over, all right? So you have a pi, and then you have a cubed All right, then here, the next part is we have to plug in A. So you would have a K up there, so I'm going to put K. Then we have A to the 4th power, A to the 4th power. All right, then you can see that we can actually do a little bit of cancellation. So you're going to cancel that, and then you can cancel that one. All right, and then you're going to have over 4. So you're going to have a 4 here. All right, so that's everyone, right? So I'm going to say divide by 2, so that's 3. Divide by 2, that's 2. And that's what we get. Let's see, I have to probably get rid of that one. Yeah. All right. So you have a 3Ka over 2 pi. All right. Then that's the, let's see. So that, and, oh, actually, oh, sorry. I made a mistake here. All right, this K is actually gone, so this K is actually canceled out. So there's no K here, and there's no K there. All right, so it looks like it's going to be 0, 3A over 2 pi. All right, so let's check the answer. All right, submit for testing. All right, I came back and looks like we got everything correctly. All right, that's it. I hope that this was clear.